Hello, hello. Let me get the stream up. I actually met up with some people tonight, like socially, and had a little bit to drink. So I'm not 100% sober. So that'll be entertaining for you people. So we're going to work some more on the Apollo Time stuff. I also am moving my tea setup into here because in my old apartment, the kitchen and my workspace were like one room and it was really handy. But here that's not true. So I'm like setting up my tea station over here. But I can't check in the Apollo Time stuff on my laptop because I changed the name of a variable and I didn't change it everywhere. So I need to get that compiling and stuff. And the problem is I need to get it compiling and stuff where you guys can't see it because it's on my laptop. But it's okay. Wrong microphone. What do you mean wrong microphone? Is audio messed up? What are you talking about? Looks fine. Looks fine. Don't ever shop for snacks at CVS while you're slightly tipsy. You get so many crappy snacks, I tell you guys. All right. I should get like a whole snack cabinet in here. Like a nice display / availability cabinet for snacks. I think that would be great. I think that would be great. Yeah, we should also set up the chai cam. I do have a brand new chai jug of fresh chai. Like, I don't know when I drink it tonight though, because it's late and I don't want to do a lot of caffeine and sugar. Snack cabinet with our... Yeah, okay, guys, what if I got one of those super pimped out gamer PC cases with like the glass sides, kind of like I have for my current PC, and it's got like RGB lighting on the inside, but it just has snacks inside. Like, what if I did that? What if I Kickstarter funded that? And it's not to make those for people. It's just for me. I'm going to Kickstarter my own pimped out snack cabinet. Okay. Glass is bad for thermals. Tell that to the people who made this PC case. It's got like two sides of it are glass. Okay, I got to change its variable name. Hold on. We have a variable called day starting at 0. And I changed it to day of month starting at 0. So I got to go to line 800. God, we're up to line, it's almost 1,000 lines. Day of month starting at 0. Hold on. I don't have my mousy mouse. Hey, that compiles. All right. So let me try Sokoban. Okay. Now we just hope there's no check-ins. Oh, there is one. We'll change that to an incomplete. And that's the only one, hopefully, question mark. Commit more Apollo time stuff. All right, let me update the game. We'll also get anyone else's check-ins on the game. People have been working on graphics. Oh, shit. Interesting. All right. And then I get my compiler changes. Very good. Let me... Okay. So we got that. This is the value that we are currently in the process of delivering to the people. Now, people who have been on the stream the past couple nights know that we've been working on this Apollo time file, and I did a bunch of stuff on it today. Casey reminded me, or told me, I had the very fine book Hacker's Delight, and last night on the stream we were trying to do long division, and my brain wasn't doing it. And he was like, look, Hacker's Delight just has long division in it. So I implemented that today, and it works. And I also started writing documentation, and I did some other stuff. So I want to kind of go through. I want to maybe do documentation because it's going to be fun and ranty for the people. And then we can also maybe verify some things about some of these routines, make them work. Like the division right now is positive numbers only, but you can handle negative numbers by having a wrapper on the outside that checks the signs of things, flips them, calls unsigned division, and then flips them back, right? So, yeah. Okay. Let's just go to modules, basic examples. So I can show you what our time program does now. So we do a bunch of stuff. Let me show you the source. So in the process, this division algorithm, it needed some other stuff, like it needed like frickin' left shift and right shift. So we implemented these. And, if you remember, one of the things last night that we got almost the right answer to, but not quite the right answer, was if you have the maximum Apollo time, how many years is that? And we did the division to get the number of years, and it was like 5 quadrillion years. But it wasn't quite the right number of 5 quadrillion years, because when I multiplied it back, it wasn't high enough. So what we do is we do the divide. Actually, this is different. I should probably put this somewhere else. But we get the Apollo max. We say how many seconds are there in a year, or, how many seconds are there in a year, and then how many femtoseconds are there in a second. We divide by this, and then we divide by that, and that gives us how many years, and then we multiply it back out, right? We take the number of years that we got, because when you do a divide, you're going to get rid of the remainder, right? So there's some fractional year that we're throwing away. And then we take the years, we multiply it by how many seconds are in a year, and then by 10 to the 15. And then we say, what do we get? And this result should be almost Apollo max, but not quite. It should be off, though, by less than the number of seconds in a year. And so we get that now. So we have, look, it's 5 quadrillion years is our range in the future that we can store using this time counter. And when we multiply that back, we get something with 7 and a lot of F's. And then it only stops saying F to pay respect toward the bottom of the high word and then the low word, right? And the deal is, this is how many seconds per year. Wait, this is, okay, denom is seconds per year times 10 to the 15, right? So any remainder that we get has to be less than this, and it is. So that's how we know it's probably right. So that's what I've been doing. And then this is Apollo Max, because that's a sort of stress test number a little bit. Divide that by 1, it better come out the same. Divide it by 2, and the low bits are the same, which seems wrong, except they're all Fs, right? And so if you divide by 2, I guess it's still the same. It seems right, maybe. But this is half, right? That's half of that. Is Hacker's Delight good? Yes. Hacker's Delight is good. Any questions about what I just said? The F word. Well, the F word is -1, actually. It's a good point, though. Let me turn off the air conditioning. So this is also, by the way, now deployed in the game. So when I run the game, let me run the game. I'm in the wrong window. I'm compiling the game. Oh, we got a not. We still have a weird x64 bug. So I'm compiling the game. I'm running the game. Now we can load other campaigns, like save slots, which we didn't used to be able to manually do before. And that was the impetus for all this Apollo time stuff, because I needed to put a timestamp in the save file and etc. So, well, we're loading. Come on, man. Joe Biden wants you to load. Oh, I got to take care of that problem. I got to take care of that problem later. Did I end up using one of the Hacker's Delight algorithms? Yes. Anyway, so this here is Apollo time now printing that timestamp. I only have one campaign on this computer, but if we start another one, this is a debug build, so we're kind of laggy. But I start another one, I run around, and then I go load a campaign, and now we have 2 campaigns. Oh, I say inaccurate for old campaigns on Zero Solve just because people have a bunch of old stuff on their disk that didn't have that number in it, right? But anyway, March 7, 8:56 p.m. So these are Apollo times in there that we're using, and so the Apollo time to string works fine, although it goes through Windows to do this right now, which sucks. I would like to transcribe some algorithm for figuring out the month and day and all that, right? I need to look up like how to do that. That's not the kind of thing that's going to be in Hacker's Delight. Okay, I can show the Hacker's Delight stuff that I did today. I did basically go to that division algorithm. It took a little bit. So the division algorithm, by the way, used bit shifts. So I implemented bit shift operators, and these are longer than they might be because you know how shifts on x86 are faster if they're constant. So we say if you happen to pass a constant argument to this function, we do this one, which is like shift left by x, which is just a constant here, right? Otherwise, if it's not constant, we like load it into R or CL, I guess, right? Because it's 1 byte, and shift by CL. But yeah, code quality. Sometimes code quality means your function is longer. Anyway, so we can left shift, we can right shift, and then this is the Hacker's Delight algorithm. And then this, in that algorithm in the book, it's not 9.5, it's 9-5. They have this function called divu. And it's weird the way they write it because they always call divu and then mask by the low 32 bits. In this case, so in the Hacker's Delight, it's a 32-bit native word, and then they're doing 64-bit multiplication. We're doing the same thing, but 128-bit multiplication with 64-bit native word. And the way they wrote it, it's weird. They're like returning the large size and then anding by the bottom 32 bits every single time. And so I just said, no, just return the bottom, right? And that's why this is called FF, because in the book it's and FFFFFFFF every time. And I just said, no, we're just going to return that. And so this looks a little different than their book version, and it's a little bit longer because they were using like long longs, which is 64-bit. Like long longs, it's very weird to me because in the book they use long longs, but then they wrote division, where I would think that if your compiler supports the type long long, your compiler would just support division. So that seemed very strange. But here we don't have a long, right? So these are just things with a 64-bit high word and 64-bit low word, and we wrote those parts out explicitly, right? And used some assembly in a couple places. But it's the same as the Hacker's Delight algorithm, and it appears to work so far. We'll see. This isn't the variable size word one. They have one that's like specifically like double wide. Would 128 be long? Yeah, but I like the joke of long. It's better. Long duck dong. Exactly right. Anyway, so we now get the right answer. So now when we say how many years in the future can we get, and then we multiply that back out, here's the number we get, which is off from, the max positive number by by 2 digits in the high word, right? And then some low word. And then the femtoseconds per year is this, which is 3 digits in the high word. So we're actually off by like a plausible amount, as opposed to last time when we were off by more than this, which told us that our division was wrong. So I don't really know. I haven't stress tested this. I don't really know that it's right in all cases. But it was wrong initially, and I fixed some stuff. So like it's not totally wrong. Yeah. Anyway, if you look in the book for the one that says div u a bunch of times, that's which one this is. And then they also did, so the thing is, we're not handling negative numbers yet. So I need to put sort of the wrapper around the outside for that. And then I need to check multiplication. So there were a couple things, like right before the division stuff in the book, they have multiplication stuff. And they're like, hey, if you do an unsigned multiplication, you could turn it into signed with the following fix-up. And that makes this easier to think about. Except they also said, hey, or no, I read it somewhere else. When you do this kind of multiplication that produces a double-sized result, somebody asserted, and we could verify that this is true, but they asserted that the bottom half of the result is the same, regardless of whether it's a signed or an unsigned multiply, and only the top half changes. And I think what that means is that for this multiply, we don't need to do anything different for signed versus unsigned, because we only keep bottom halves, except when multiplying bottom by bottom. And in that case, those are both unsigned anyway, I guess. I don't know how to think about it. It's weird. But so I just have to verify that multiply does something plausible for negative numbers, and or figure out what the hell if it doesn't. Let's show multiply. Where'd it go? Come on, bruh. There we go. So this is my multiply that I wrote, and it's basically, I didn't even really look in the book for this, right? Because this is just easy to think about. It's just the cross terms, like, 8 times 2 to the 64, or HA times 2 to the 64 plus LA for high and low times B, HB times 2 to the 64, right? You write that out, you multiply out the cross terms, and you note that the high term is way too big to store anyway. That's just going to wrap. So you discard that one, and then you just compute the rest of the terms. And that's all I did here. And then I read Hacker's Delight about multiplication, but it didn't seem to, like, they were mostly concerned with, like, hey, if you need to do a signed multiply and you only have an unsigned multiply instruction or something, but we have both, right? I'm doing imul. Maybe I should do mul. I don't know if it matters. I mean, I guess we were saying it's the same. I guess, though, for this one where we keep the high, maybe I shouldn't do imul. Should this just be mul? I kind of feel like this one should just be mul. But I don't actually know. Only signed mul low. Yeah. I just don't know. It's weird for me to think about, right? So these are 128-bit numbers. They're officially signed, but when we declare the data structure, I just sort of said the low bits are unsigned. Why? Because it's weird to think about them having a separate signed bit. I don't know how to write what this should be. I don't know if it matters, right? And then here, I don't understand multiplication in 2's complement well enough to know when I multiply low times low and get a 128-bit result, should that be a signed high or an unsigned? I feel like it should be unsigned, but I don't know. And maybe actually what really matters is how you add. Because, we accumulate, basically we get this high word and that goes into high sum, right? And then we keep adding things into high sum for these different terms. And maybe that has to be a thing. I don't frickin' know. Do I need to change the other imuls to mul? No, because the theory is that the low is always the same, whether it's signed or unsigned, and here we only keep the low. Right, because the low, so these terms are A times 2 to the 64 plus B, and B times 2 to the 64 plus A, although not A and B, because A and B are the whatever. But it's one term times 2 to the 64 plus, or no, it's one term times 2 to the 64 times another term. So like the high just goes off the edge. It's gone. If you write it out, it'll be obvious, right? So this high sum, so when you do this multiply, it's whatever's in one word times whatever's in another word times 2 to the 64, right? And so the instruction gives you a result high and a result low, but you put the result low times 2 to the 64, so it goes in the high sum, and result high times 2 to the 64 is just too big to even store in 128 bits, so you throw it away. That's what I'm trying to say. Q suffix isn't required because it is the default. Yeah, I don't know. What I will say, we can talk about this later if we want, but for this kind of code where, like mul instructions and div instructions, like they want to use D and A, right? But they also use those for inputs. And so if I'm only allowed to bind like one name to a register, which I can't, I tried binding another one, and if you do it the default way, it just says, hey, error, right? But I kind of feel like it maybe should be an option to do that, because the problem that happens is I start getting, you almost can't create a helpful variable name because it's being used for multiple contradictory things, right? So like here, we're moving into result low. It's called result low because it's the result of the multiply, but like it's an input here, right? And I'm only doing this because I'm forced to use A for the multiply. This actually isn't the worst one, but I think in div it gets worse somewhere. I just remember having a hard time with it today. I don't know. It's bad maybe in the shifts. I don't know. It gets bad somewhere. You could rename a register with whatever. Yeah, I mean, if there was just some simple syntax to make an alias, because I do think we want to guard against mistakes, right? But if somebody wants two names for a given register, that seems like it would be helpful on x86. I don't know about other CPUs, but it got a significant amount of confusion today happened. Like I guess I'm a little bit verbal when I program, which is part of why I don't like abbreviations. Like I don't like my brain to be reading like stuttering syllables all the time, which is why I hate putter from C++ and stuff. And so when I read like the wrong name for something, it confuses me. And then I have to, yeah. So that would be cool. But otherwise, I mean, I had a good time programming this. Like, it's pretty fun to do assembly now. Okay, so it's more of a thing with scalar stuff since you don't have the 3 operand form that specifies a separate dest. I don't know what is more of a thing with scalar stuff. Do you mean the renaming problems? Yeah, right. Yeah, that makes sense. But I will say, I mean, I've had a good time programming in assembly. I worry a little bit. So, I try to think long term, and I'm starting to think about like what happens when we support 10 CPUs and what does all this code look like? Because, okay, so we kind of have an n squared problem in this language. Okay, let's rewind. For all the people out there, for all the 222 viewers out there, okay? Part of the core thesis of this programming language is that you should understand the code that your program uses for the most part, right? And that means, if you use some font rendering or something, you ship that source with your program. I mean, unless you license a commercial one or something. But like font rendering isn't hidden in the operating system because you probably get picky about how you want to do it, right? Especially in games. That's just a random, it's just an example of some library code, right? But the point being, you're not supposed to be afraid to look at how things are implemented. And then also, when we ship a module, which is the version of libraries in this language, and the only reason I call it modules is because we also link to C++ libraries, and using the same name for two different things is confusing, right? So when you ship one of those, if its source is available, then you sort of, what am I trying to say? Like, you archive the source with your program so you can recompile your program much later, and you should be able to recompile your program for any operating system or CPU that module supported when you copied it, right? And so I just wonder, now that we're doing a significant amount of assembly, and then we also have like if Windows in some places and if Linux and stuff, so we kind of have this like number of operating systems times number of assembly language problems, where maybe if we do too much low-level stuff, like the source code starts to blow up with all of these like different implementations. And that hasn't happened yet. It's totally chill, but like the Apollo time file here is like 1,000 lines right now. A significant amount of that is comments, and that's going to get bigger. But like a significant amount of that 1,000 lines is assembly. And so like if we do ARM, that's going to double. Fortunately, I don't think there's any like window. Oh, there is actually, right? There's some if Windows stuff in here. But some of that is because we don't have our algorithm for converting to calendar time yet. So that'll go away, but still there will be some if windows in here, which is like, how do you get the current time from the operating system in Windows? We're using this, and then we have to convert that to our representation that's cross-platform, right? So I worry a little bit about the M times N thing, and I don't know, maybe there's not a good answer to it, and it's just what we're going to have to deal with. Does the assembly go through the optimizations pipeline? We talked about this. I think there's a small number of transformations that maybe happen on assembly a little bit, but for the most part, okay. What I think it is that when you write assembly, you're telling the computer what you want to happen. So I don't think the compiler should really mess with that, unless you somehow like manually turn on a flag that says like, hey, do whatever you want with this. But I think when somebody goes through the effort to write assembly, it's because they're telling you what should happen and you should listen to them, right? I don't actually know what LLVM does. I don't know if we have control over that. More like N plus M. Yeah, I mean, okay, it's kind of N plus M, but then like if we do the assembly inside the if Windows or if Linux or whatever, then we have to like factor it out into macros that we call from either one, and that just adds a little bit of complexity. It's not that bad though. But I guess you're right. If it's only N plus M, it's like not that bad. We'll see. I mean, we'll cross that bridge when we come to it. I will say I'm very happy with how things are going. It's going great. It's really fun to program in. The only thing that keeps my life from being maximum fun right now is because I have so much work to do on so many projects. So I'm always stressed out because I'm the bottleneck on everything. But dude, it's really fun. Just like the fact that I have this really high level programming language and then I can just do assembly in the middle of it is like, it's so obviously the right thing. And not just grody assembly, but like good assembly. It works great. I'm a fan. I'm a fan of it. Which also means I want to move us toward closed beta soon, but oh my God, I've been talking to lawyers about some other thing and it just takes so long. All right, let's start talking. Let's start writing the documentation here. We could zoom in on the file a little bit. So I've already sort of written the introduction, and I started getting a little bit philosophical and ranty. This can be a fun audience participation. If you don't believe some of what I'm saying, you can push back on it, and I can try to make a better explanation. Don't worry, I'm right about what I'm saying here, but the question is, how do you cover all the bases in terms of explaining it to people? Accessing stack stuff right now. I have to take pointer stuff. Oh, yeah. Let's talk about that before we do this. I was going to send an email about this, but I'm not totally sure how to think about it. So I am, in stuff like this, I am manually taking a pointer, right? In a lot of cases. I'm looking for one. Here. Okay, so here's an example, right? This is on the stack. Here we take a pointer. Now, the thing is, in the front end and middle end of the compiler, right? This thing is there's a function called treat as big argument, I think, where the word argument is old and apocryphal, but it's basically for the calling convention, right? If things are register sized or below and not a struct, then they're by value. Otherwise, they're like by reference, right? So this thing is by reference, which means in the bytecode, anytime we talk about the value to this, it's actually a reference, right? And that lets us just store the value in one register and whatever. And then if you assign, then we copy from that, right? But what that means is it should be a trivial amount of code to let me just, instead of saying R, taking the pointer explicitly, to let me do this down here, because this, like the entire bytecode builder already, this is a pointer anyway, right? So I feel like that's a small change. The difference, though, that would be inconsistent then is that if you have something like, you can have a small value that is also on the stack. Like that happens if somebody takes a pointer to a small value. And then that doesn't work the same. But for this, it's literally no extra code, I don't think. So the question is it a weird special case to make this work, or is it just natural? That's all. Is it called treat as big argument still? Let's see. Treat as big. Dude, this function goes back to 2014, probably. I mean, it's changed, but okay, guys, look at this. Treat as big argument. I'm going to select it. Go to definition. I would like to see the definition of treat as big argument, please. Oh, we're in the middle of some function called print instruction frequency that isn't even compiled in because it's grayed out and info. Like Microsoft, what is going on? Like literally what is going on? How do people say software is good today? This happens all the time. Like this happens to me a lot. And people say, like, how can you live without IDEs? And I'm like, because this is IDEs right here. Common Lisp's handling of time. I mean, I don't like almost anything about Common Lisp, but I'll go read that. Okay. Not on stream, though. Anyway, if I could find this function, let's try going there from somewhere else. Nope, same place. Like, it's not even the right file, right? Like, if I... Here it is. Oh, it is the right file. It's just like 40 lines off for some reason. Yeah, anyway... If this function returns true, then the thing on the stack is actually just a pointer anyway, is what I'm trying to say. And you could just use it. And you call emit L value, or no. I mean, I guess if you know the stack address, you don't even need to do that because you just know the stack address, right? Like you could call emit L value and get the pointer, but that would create an instruction. And I guess what you're saying is you could just translate the move, because if you're doing memory plus something, then it can just be stack plus a bigger number. Yeah. Okay. Anyway. Have I considered other workflows that don't involve... I don't use IDE. Have you ever watched the stream, please? Like, I use this to debug. It's very rare that I use it for anything else. I use this to type code. Okay, let me get a popcorn snack. Back in a second. Any other questions before we rant about things? You could read ahead if you want. right, we got caramel popcorn snack, everybody. Thought is to gen the RSP plus X. Yeah, I mean, that's slightly weird because it's like not exactly what the user said, and assembly is about doing what the user said, but because you know you're interfacing with like a variable in the outer language, so like what do you expect, right? Like it's going to do something. So I think it's fine. My feeling is it's fine. Yeah. It's either RSP or it's the register assigned to the pointer they are using. So there's other cases that can come up, right? So if you use the using keyword, you could like be using through 5 different pointers, right? And in that case, I'm fine with saying, please manually load the pointer yourself to use it in assembly. I mean, if you want to do that, you could. Like the bytecode will do it for you. It's just like there's a question of how automatic to be when we're in this low level programming mode, right? Yeah, I don't know. So, do you mean Q is the default for every single instruction? So .q is completely optional. I think I have like one .b. Yeah. So I would put the .b here, but the rest of these are not necessary. Is that correct? .q is the default in 64-bit mode. Okay, great. Let's try it. I'm not going to bulk replace because that's a little bit too scary. Look at all these .q's. Whoop. See, there we go. That's why you can't be too overzealous. All right. All right. Let's see if that works. No, wrong program. Oh, looks like it worked. Great. It's almost like deleting a line or two. Tell that to the line counter. They won't believe you. It is more readable. Okay. It's also important to do quality of life stuff like that in files like this that people are likely to read, because people are learning how to use the language from reading code like this. And if they see .q every single time, they'll do that. So, yeah. All right. Okay. Question and answer. Isn't it overkill to have 128-bit time? the history of computing platforms to date is full of... Let me talk this through before I type it, right? What I want to say is that the history of computing platforms is like we pick a time value that seems fine and we convince ourselves that it's fine, and then like 10 years later it's totally not fine, right? So like on Unix systems today, you have time t, you have time val, you have time spec, and you have tm, and you still have a year 2038 problem, right? So like the goal is just what the don't we know better than this by now, right? Like, don't we frickin' know that this is a problem? And so let's solve, like, if you're going to solve the problem, solve the problem. Does that make sense to people? Is there more that I should say there? What's the year 2038 problem? So do you remember the year 2000 problem? When like everyone was afraid that all the software would break because Fortran programs used like 2-digit integers for the year. Year 2038 is when the number of milliseconds since 1970 becomes 32 bits. And all the timers in Unix overflow. I mean, I guess. So how is this handled now, right? Like in Linux today, I don't think they changed the size of time t, or like they can't change the size of all those data structures. So like, how are they solving the 2038 problem? Or is nobody worrying about it yet? Are they going to introduce yet another new data structure? Pretty sure we don't care yet. Great, that's going to be fun. Anyway, with the Y2K problem, the reason it wasn't a giant disaster is that everybody took it seriously, and just fixed all the software. It was like a massive effort. The problem is it's going to be an even more massive effort for the 2038 problem because there's so much more software, and every individual piece of software is so much bigger than it was in the year 2000. There's just so many more lines of code. With Linux 5.6, 64-bit time t is supported. So if you recompile a program, is time t automatically 64-bit? Doesn't that break some programs that save it out or whatever? I guess if on Linux you think everything is text, it's not that bad. Simulating very short periods of time with extreme precisions. Yeah, I mean, for very special problem domains like that, I don't think you would use this in your core loop. I mean, you might. Like, the thing is, like, time computations actually don't. That's another reason why this seems like the right trade-off is, like, they just don't cost that much. Yeah. Like, also, like, if you're going to write a profiler that uses, like, RDTSC or something to figure out what time it is, I don't think you convert that to this, because a profiler is a very domain-specific thing that wants to know about CPU cycles. So I think you just keep it in whatever each CPU says. Something like the date object in JavaScript can't go past 2038. No, JavaScript is even worse. I mean, I don't know about the date object. I don't know what the format is, but JavaScript uses floating point numbers, which means that as time goes on, you get less and less sure what time it is. Easy, Sag. But they're probably using double precision floating point or something, which means they don't have a year 2038 problem specifically, but like, you know. When would the next 2038 problem be if we started using 64-bit integers? Well, here's the thing: is it depends. It depends what the 64-bit integer stores, right? If you store milliseconds, it won't be for a really long time, right? I mean, okay, so 32 bits gives you 4 billion, right? And so if we ran out of 32 bits in 50 years, approximately, right? Then multiplying that by another 32 bits worth of content gives you 4 billion times 50 years. This is a long time. We probably don't have to worry about that. If your timestamp is milliseconds, but like milliseconds aren't that good. We can't use a millisecond timestamp in games because our frame is like 4 milliseconds long if somebody's got a 240 hertz monitor, right? Like we can't, like if that's your most precise time representation, everything's going to be jittering all over the place. So, you know, like milliseconds are inappropriate for a large number of uses. And so you start saying, well, maybe we should have more accuracy than that. I do think many people would consider actually, hold on. What I said was wrong about 4 billion times 50 years. Because the 50 years, the 32 bits in 50 years is actually number of seconds. Okay? Right? And then something like TimeSpec stores microseconds in a separate 32-bit number. So like everybody already moved to 64-bit is the answer to try to get more precision. So if you said 64-bit in terms of number of seconds, yeah, then it's, 200 billion years. However, you can't talk about dates before 1970 using that system, and you can't get more precision than 1 second without adding even more data, right? This popcorn is really good. Do you care about the scale of decades, centuries? Well, it's an engineering. Okay, engineering is all about trade-offs, right? How much effort do you spend trying to deal with that versus like how much CPU and memory are you saving by only using 64 bits instead of 128? That's the question to answer. And what I'm going to try to express in this answer here is like, I don't think it's worth it. I think we should just like have a time value that is so good that for almost any application, you just don't have to think about it, because our limiting factor, okay, this is an additional thing to say. Our limiting factor in software is complexity. That's what limits how much we're able to do. Like the reason Visual Studio is shitty and couldn't even jump to the right file where or the right line in the file where my function was, is because it's just a really complicated program with a lot of problems and people are drowning in problems, right? That is the limiting factor today. Now, people have known that for a long time, and all these new programming languages have different ideas about how do we make programming more simple. Well, we do it by having the programmer not think about memory or whatever, right? This is just a different, much smaller answer to like, how do you make programming more simple? Well, this one thing that causes all these fucked up bugs, we can fix that, right? And it doesn't cost much. And so let's just do that. That's the thesis here. Yeah, 128 bits is a lot for a timer. Yeah, I think... Oh, it's 5 quadrillion years, right? Not quintillion. Hold up. I don't want to false advertise. I don't know if I said quintillion, but okay. Hundreds, thousands, million, billion, trillion, quadrillion. It is only 5 quadrillion years. It is not 5 quintillion years, which is 1,000 times as many years. No. We are limited to 5 quadrillion years. Okay. Oh, if Ryan's still on, it occurs to me to point out, maybe you saw this earlier, but in the shift operators in this file, which this version is plugged in, this was a good, nice and organic use of high-level features combined with assembly features, because here it's like, so we have this operator overload for left shift and right shift of these 128-bit values, and if the shift amount happens to be constant, we like use the constant form of shift, right? And that happens syntactically automatically, right? Because the assembler says, oh, this X is a constant, so we sub it, right? If it's not constant, we have to load it into C and then use it, right? And that's a slightly slow, it's an extra instruction. And then, is it like latency 4 these days? I don't even know. But I thought that was pretty cool. It was pretty fun to do that. It's like, oh, we can do a better version of it or a slightly less better version of it. had to re-up my popcorn subscription. Good thing Insobot isn't claiming it's 5 quintillion years. I would have been sued by now. Okay. And still somehow we have a problem wherein we need to expend a great deal of effort to revamp all this software prior to the year 2038 before it stops working due to running out of due to numerical overflow. Because it's not just time t. It's like if you have a time spec that has a 32-bit, seconds member in it, on Mac, time t is 64 bits. They probably changed that a long time ago. The problem though is, okay, I was reading some code on Stack Overflow that said, hey, if you have a time spec, just pass the address of it into something that wants time t because it's just a pointer to the time t, right? So if you change the size of time t, you have to change the size of time spec and all these other things. Or if you didn't do that, so if you don't do that, you'll break programs that pass the pointer. And if you don't do that, it won't really solve the problem because you'll have all these time structures that are too small, right? On the other hand, if you do it, you change the sizes of these structs, which probably breaks some software. I mean, for sure it breaks some software. It's just who knows which. And then there's other complications like modification times are stored in the file system. So you need 64-bit mod times there. There's all sorts of things. I think I don't have to do the extra move. I can bind the arg to C directly. In the shift, do you mean? Hold on. It took me a while to see that comment. For this. Right. So I just do that. All right. Didn't like that. Oh, because I need to change that. I mean, it looks like it works. That's cool. I don't actually assert on these yet, so I have to visually verify. All right, looks like it works. Now, if I wanted to be very sly, could I do this? Does this work? Because I know you did a thing where ASM blocks chain into each other, and I haven't really done that. But like, could we do the following? While I play code golf here, could we do this and then just do that? Because it'll pick. Wait, no. If not constant. Does that compile? Yes. Oh, that's so good. Check it out, guys. Look at this programming language right here. It looks like JavaScript right there. The triple equals. That's JavaScript. Okay. So if x is not constant, we bind it to register C, and then we just do this. That's dope. I could also have this be an assembly instruction. I just didn't want to. I mean, I think this has to be arithmetic shift. Is it ASR? We don't know that. How do we do an arithmetic shift right? Oh, SAR. It was called ASR on like the TRS-80 color computer from the 1980s. And that's why I remember that. All right, and then let's try to do this. So shul p plus 0x, right? Actually, so when we do this, does this modify low? Because we could just store it, and that might be faster. Second operand provides bits to shift. I always find this hard to read. It looks like we don't modify that. So we can't just store it. We do a second shift here. These are better, though. Look how much better that is than what it was. There's no such thing as shift arithmetic left. Is there? Why would there be a what? Yeah, there's no... Wait, there is. What? What does it even do? Is it an alias for shift left? C1/4. They don't, there isn't even... C1/, it's just an alias. It's the same instruction because it doesn't do anything to keep the OCD at bay. You're scared to ask what triple equal was. It binds a variable name to a specific register. So this is a higher level assembly that Ryan designed. He's in the chat. And one of its good features is that you don't have to specify specific machine registers, which is one of the big butt pains of programming in assembly language, right? Because you have to map out what's stored where, and it takes a lot of your thought, and then you change something and you have to move it all around. You don't have to do any of that here, and it makes it a lot easier. However, on some CPUs, such as the Intel CPUs, some instructions require values to be in certain registers, right? And so in those cases, you can specify. So a shift by a variable amount requires that variable amount to be in CL, which is the 1 byte low byte of the C register. And so here we're saying if X is not constant, make sure it's in the C register, please. And then this instruction is valid. And this one. I'm not getting very far in the documentation. What? Okay, check it out. Things are good. I've almost eaten my second bowl of popcorn. I am getting further on getting fat. I am not getting further on writing the documentation. But we made these functions better. I'll put that on my resume. I made operator left shift and right shift for Apollo time better. And again, any syntax you see might change, right? I don't care that much about syntax. It's all about making things work right now. So like maybe this won't be double equal in the end. Maybe this won't be hash asm. Maybe this won't be hash if. I don't know, right? Maybe you won't say operator here. Whatever. This is just like we're establishing how the language works. And then later we could tweak surface properties of it. Is there a compilation error if you don't put that triple equal line? I would guess that you probably get a compilation error most of the time, unless it happens to pick C. The thing is, oh, you know what? Oh no, I was going to say we don't call this with a variable number, but we do call it with a variable number because the divide algorithm uses a variable argument. So if I comment this out, yeah, it's upset. I don't know what register it tried to pick for X. Or maybe it does require a binding, but I'm not sure that it does. Anyway, it's saying, hey, look, there's one with an immediate, which is a constant, right? Immediate is the assembly language name for a constant. And there's one that takes the C register. By the way, Ryan, if you're still on, one thing in addition to the naming stuff, I feel like maybe sometimes I want to say GPR.C or whatever, especially because that's what these error messages say. So that might be a thing. I don't actually know. Maybe I want more experience using it to know that, but like sometimes if I know I need to use the C register for a couple instructions, I just want to do it. I don't know. Anyway. Okay, let me at least get a couple sentences of documentation done. Okay. Other systems have problems that are similar but different than when we want to deploy a robust program across all these systems. We start drowning in all the details. Shouldn't we have learned by now that we need a lot of range and precision in our time variables? Instead of kicking the can down the road by adding slightly more each time we run into a problem, why not just hit the problem with a giant hammer and solve it for a very long time? If the cost is low, if the cost of the solution is low and the amount of benefit is high, this would clearly be the right decision. Change tense here. This, I don't know. Were low. In this case, it seems clearly to be true. Timestamps are not. Timestamp data is a small minority of the data stored by programs, and manipulations of this data are a very small percentage, a very small fraction of CPU cycles. So adding more overhead here by doubling the size. Has a small cost in reality, but the benefit is big because we remove a huge class of problems and uncertainties. Software today tends to be very buggy, and it tends not to do much more than software did, I say 30 years ago. It is limited by complexity. The programmers just have too much to do, too many complex scenarios to think about, too many bugs to fix. To the extent we can reduce this, we should, and software will be better for it. But it must be said that a large the vast majority, a lot of this complexity is self-induced by programmers' lack of appropriate aesthetics. All this said, most people who tell you how you should program are always saying that if you do X, then everything will be great and it's obviously better. But if this were true in even a minority, I need a better word than minority. Like I'm thinking of a word like a non-negligible minority, right? If this were true in even a minority of these cases, software would have improved over time. Yet we observe that software has not improved much. So clearly, what most of these people have been saying has been wrong. In this specific case, though, I don't know. This is a weird argument to make because people who try to tell you to like use a garbage collector or whatever will point you at people's memory bugs. I was about to say because of this history of time problems, clearly this is a beneficial case and it's not like all this other stuff. Maybe this is becoming too tangential though, and I should delete it because I could try to write a lot more to argue this effectively, but it becomes more and more off the main point. But the problem is, as soon as I say this, it's like, this is what people say all the time. So good content, but not a QA. You must be new to this stream. Oh, did I I gotta re-comment that so we compile again. Whoops. No, you guys, sometimes I am in the mood. Okay, the reason I'm writing a lot here, and we have done this before on this stream, the reason I am writing a lot here is because documentation is usually bad. Why is documentation usually bad? Well, A, it doesn't tell you the objective personal things that you need to know. Like, what the hell does this function do? Can I call it in this way? Okay. B, Well, actually, before that, documentation often doesn't even exist, right? Okay. B, documentation is often written in this kind of like super, I don't know a better word. Like the way the like Twitter assholes would do it is they would say it's written in a very autistic way, and I don't have a better way to say it than that. But it's written in a way where it's like, these are the features and these are the functions, and here you go, like a reference kind of a way. And that's not what you want, or not what most people want, and it's certainly not what I want. What you want is like, how is this meant to be used, right? What is a good idea when using this, and what's a bad idea, and all that, right? And then there's another layer that documentation basically almost never, ever, ever has, which is like, what is the tacit knowledge behind this system? Like, why does it work the way it does? What if I want to learn to make decisions of the same quality level or better as the people who made this? What should I be thinking about? What do I need to understand, right? Why is this function set up this way instead of a different way that I might obviously think of? What is the reasoning, right? And documentation almost never has that. But that's what you really want to know to be a quality programmer. And so I'm trying to provide some of that sometimes. And then sometimes I have fun with it and rant. But the ranting serves a purpose, and the purpose is to attempt to communicate tacit knowledge. And if you don't like it, you can skip the comment anyway. So it's fine. The downside is this comment gets compiled every single time somebody compiles a program. But it's fine. What do I think about the people who say you don't need documentation, the code documents itself? I would repeat what I just said. The code does not tell you the tacit knowledge behind the code. That is just not a thing. Okay. Boom. Why should a usage guide and a design rationale ever be the same document? Because I mean, what's your model? Is your model that people should use things that they don't totally understand? I mean, I guess that's the case. I don't know. Like, if you drive a car, you don't understand the car. I just feel like software as it exists today is not like a car. Like, if you're programming to an API, you can't be as oblivious about how it works as you are with a car. I don't think. Like, that turns out badly because software isn't good enough. Like, our technology of software is not good enough to let you do that. Straussian code. Yeah. For the 3 people in chat who know what that means. Okay. So I don't want to go as far off on this rant as I am going. So maybe I'll make an aside. I'm just going to compress this last paragraph that I was writing down into a small point and say, okay, there we go. if we want gigahertz accuracy, we would only get 292 years of range in 64 bits. 128 bits just kills this problem dead and allows us to have, not sus, allows us to have much more accuracy. Even just for applications that start a timer at 0 on startup. Do you want to be writing programs without crashing? Okay. That's enough on that question. In the case of cars, we actually do provide some rationale documentation like the driver's manual. Yeah, we just don't explain stuff like how the engine works, right? For cars, or why the engine is the way it is. Oh, I need to drink less alcohol, guys. I drank tonight for the first time in more than a month. And now I've got a headache. Okay. Why not use a different 0 point? Like trying to be more compatible with one of the already established time conventions, such as Unix's January 1st, 1970, or Windows January 1, 1601. We choose to take this opportunity rather than throw it away. Entire life, he has never seen a feat of technology that comes close to Apollo. If you don't go to the moon for 5 or 10 years, maybe you just didn't want to. Maybe you felt it's a little too expensive. Not now, I have a headache, and so forth. Not now, I have a headache. But if this situation continues and you don't go to the moon for 2 generations of people, that's a totally different thing. At the current time, the USA is no longer capable of landing on the moon, nor has it been for almost my entire life. When was the last moon landing? 1977? List of moon landings. It might be 79. Okay, this includes unmanned. No, missions by date. Why is this an image? Okay. 1972? Really? Okay, hold on. They have to say crewed now because it's not polite to say manned. Dude, like, what is wrong with finding information on the internet now? I guess there were only 6 moon landings. What? This is exactly what I wanted to see right here. Okay. That's wonderful. All right. So if it's only the Apollo missions, we could go back. Anyway, it's like 1975, I guess is the point. It was 1972. Okay. That is pretty close to my entire life. Although you could argue that for a while after 1972, we still had the capability to go to the moon if we wanted to, right? Okay. If we are not in denial, we must admit that technology appears to have stagnated or gone backwards in that area. People don't like to admit this, but when you peaked 50 years ago, I mean, come on. All right. Which is pretty close in... Okay, so what's my point here? I sort of then dropped this, because this was just notes that I was typing in. Okay, let's move this part. All this said, there is an initiative toward Moon and Mars landings that appears strong. So hopefully we can make it back there. And this will take a great deal of hard work and perseverant engineering. Let's get rid of the hard work. That's good. Aren't there already plans to go back to the moon? What did I just say in the paragraph? In the paragraph, I'm saying there are plans to go back to the moon. However, plans are different from actually doing it, right? Okay. So hopefully we can make it. So hopefully we can recover. Okay. Let's just say, okay, so the way to tie all this together is then to say, in our view, this is the royal we, because I don't care if anyone agrees with me, software has undergone a similar period of stagnation. This programming language and the accompanying user level code, including Apollo time, is the best effort we know how to make with the meager resources at our disposal. To try to jumpstart, I don't know, like to try to kick software's ass into gear. Like even that is to try to contribute toward moving software technology forward again. This brings us to the idea of using the Unix timestamp, which is pretty close to the Apollo landing and seems cleaner because it starts at the beginning of a year. Well, Unix was good at the time, but we should be moving past it. Yet even 52 years later, we seem to be unable, and this is deeply sad in some way. Meanwhile, the Unix we have becomes worse over time, and then it becomes tremendously more complicated while offering a relatively small amount of matter. We would like to do something about all this if we can. And then our Kennedy quote, written by, what's his name, Sorensen. Should probably mention that we should not use monkeys who know sign language because they might ask questions about what we are doing and why. Yes, that is an important point. That is an important point. Give the people the tools now. Well, we'll do it sometime. I mean, this is sort of like, you know, there was this whole dispute around the time people started saying the compiler is smarter than you, right? They also started saying, I'm trying to remember through my alcohol headache. There was this whole thing about good enough versus the right thing, right? Where, you know, if you go off in a corner and work on the right thing, you get beaten by somebody who just releases something good enough. And that's sort of this market dynamic that clearly consistently happened for decades, right? But we see the result of that, right? Like, we're in this environment that's full of software that was the bare minimum functionally that people felt that they could ship, right? And if you're going to fix that, you just have to take a different tactic. That's the idea behind what I'm doing, is like, well, maybe the right thing wins sometimes if the person trying to do the right thing has... So the problem, there are many problems with the right thing philosophy, right? Or is right thing even the right phrase? I don't remember. Yeah, the MIT approach versus New Jersey. I actually learned it as Berkeley versus MIT approach because I went to Berkeley, but same thing. I mean, first of all, you have to actually have an accurate idea about what the right thing is, which a lot of people don't. So that's why a lot of right thing projects fail. Second, you have to have the time and the resources to work on it for as long as it takes, which some people don't, or most people don't have the resources. And then a lot of people just can't stick to projects, right? Also, things are harder to do than you thought in the beginning and all of that. So my idea behind this project is, what if I just treat it like I treat my games and I just fucking fight till the end when it's good? And we're getting there. We're getting to the point where at least I would feel comfortable doing a wider closed beta. And that's very different from how almost everybody has learned to do software. But like, if you want different results, you have to do something different. You know what I mean? So yeah. Does having a small team work on the compiler affect its ability to generate optimal machine code? We haven't worked on optimization yet. We're starting to. Right now, we rely on LLVM to generate optimized builds. Okay, anyway, that is why things have been in closed beta, or very closed beta, for a long time. It's never perfect. Oh, I know it's never perfect, but there's just a point at which I want to get it to. And it's getting there. Yeah, certainly. I mean, neither of the games, like, well, I've released more than 2 games, but neither of the famous games that I've done were perfect by any means. But they did get close enough that I was happy with them. Like, that's something that I know how to do now, right? Like, I know how to get the imperfections small enough that it's fine. Like, that is the art that I have learned. Do I think I'll be hiring again in the near future? Yeah, probably. But maybe not on the compiler side. Probably on the game side. Okay, why is landing of the lunar module uses a 0 point rather than the launch of the rocket? Because coffee is for closers. Okay. The launch of the rocket represents an ambitious effort undergone by a large organization, collection, a large whole bunch of people. An ambitious effort undergone by did I just say an ambitious effort? This kind of ambition is important and probably good to commemorate, but the landing of the lunar module represents success of the mission rather than just the attempt. And success is important. It's the only objective measure we have to help calibrate our beliefs. If beliefs result in expected outcomes, maybe they are correct. This is not a necessary or even sufficient condition. Success and failure can be random, have large random factors. But success is correlated to success in engineering. I don't want to think people are talking about like making money in life or something. Success in engineering efforts is correlated to accurate and self-consistent beliefs. If we lose our aesthetic for engineering success, we become unmoored we lose our compass. We lose our compass, our belief compass. That's a very awkward phrase. This will just say, our beliefs become unmoored. Okay. Unfortunately, let me just take out. Every time I put parentheses these days, I take them out because then I want to continue from that thought. Unfortunately, across modern Western societies, we have been deliberately mothballing. No, because mothballing implies you're going to take it out later. We've been deliberately destroying. We've been deliberately denigrating this kind of respect for engineering success. These days, community and inclusion are these days in popular engineering culture, community and inclusion are valued more than correctness. In general, we want to make people feel successful. People feel successful is the wrong word. We want to make people feel we want to avoid having people feel negative feelings, and failure can cause negative feelings, but it is mandatory on the way to engineering success to face failure first. So this is a self-destructive policy. I don't know. I'm not saying the thing that I want to say here, which is I'm trying to say that in the process of we've adopted this aesthetic without considering the damage that it does. To our ability to solve problems. And maybe it's not a coincidence, therefore, that we're not so good at solving problems anymore. Let me write that down. I'm not sure if I want to delete some of this paragraph, but this new aesthetic of social factors being more important than correctness has been adopted, has been widespread. This is an awkward phrase. I could say adopted in a widespread way, but that's just so many words. Has been adopted widely without serious consideration for the damage it may do to our ability to solve problems. Therefore, if we observe that we are no longer very good at solving problems, maybe it's not that surprising. Maybe it's not that weird, to quote Louis C.K. I don't know. Can anyone think of a better way to say this? People seem to like the additional complexity because it allows laziness. I mean, sort of, but it also doesn't allow laziness because everybody's drowning in all these crappy bugs they have to fix because of the complexity, right? So it like doesn't do what people think. Should also force you to agree with all of this. You don't get to use any of the API. Yeah, what if the first time you call get current time, it pops up a window and you have to scroll to the bottom or it's grayed out and you have to read all of this. And unlike some of these that let you just scroll to the bottom and click the checkbox, this one you have to initial on every paragraph that you agree to the terms. Okay. Worse, most engineers do not even see that this has happened. We have been living off the success established by prior generations for so long that we don't even notice we are I don't know how to say this. Basically, I want to bring this to a close and say that's why success is important. Maybe I don't need to say anything else. Maybe I don't need to say this. This is like an ancillary point. This is fine, right? Thus, we choose to do what we can to remind ourselves that that successful problem solving is the point of our endeavors, is the actual point of our endeavors. If we have fun, if we find good community and have fun talking to each other or whatever along the way, that's fine. That's fine too. But it is secondary. Because good feelings do not land a spaceship on the moon. Okay. What if engineers have purposely made software a buggy mess to lower users' expectations? I mean, that's a nice conspiracy theory, but it's not true. Like, I talked to a lot of people about this, and most programmers don't even think that software is bad. Most programmers think it's fine, and if you try and tell them that it's bad, they'll get hostile. They'll think you're an asshole, or they'll think you're incompetent. The last paragraph just repeats the bits before. Let's see. Let me rehash. Okay. Launches the ambitious effort. Didn't you ever go to grade school where they teach you to write the 5-paragraph essay that's all about repeating yourself in every paragraph and then repeating yourself at the end of the essay? This is so terrible. Okay. Ambitious effort represents a success. Success is important. No, because this is about like, yeah, I don't know. Maybe it's a little bit redundant. Let's see. But success in engineering. But successful conclusion of engineering efforts is correlated to accurate and self-consistent beliefs. If we lose our aesthetic for engineering success, our beliefs become, yeah, I don't know. I feel like there's more to say here, but I'm too tired. Okay, crosswise and saying, denigrating. Let's just delete this. Too many adjectives. We have been denigrating this kind of respect for engineering success these days. Community and inclusion are valued more than correctness. Now, community and conclusion are valued more than success. Correctness, in general, you want to avoid negative feelings. So this part doesn't, okay, this part doesn't totally gel. There's like a piece missing here. So we pretend to ourselves that engineering is really about things that create positive feelings, like being included in an engineering community. I don't know. I still feel like I'm missing something here. Is really about let me try swapping this. So failure often causes negative feelings, but it is mandatory on the way to engineering success. On the way to success, I'm saying engineering success too often. On the way to success, to face failure first. In our desire to ignore this, we pretend that engineering is really about positive social things, like being included in an engineering community. That repeats kind of what I'm saying. This new aesthetic has been adopted widely without serious consideration for the damage it may do to our ability to solve problems. So if we now observe that we are no longer good at solving problems, maybe it's not that surprising. It is very uncomfortable with using 128 bits for the time value. I mean, look at it as an experiment, Casey, right? Like, look, we're just going to provide this code. We're going to use it. We're going to provide some other standard library code that uses it, but like, people don't have to use it, and we'll just see how it goes. Like, that's my policy on it. We're just going to see how it goes. If it's a bad idea, we'll find out empirically that it's a bad idea, right? And in the meantime, I had fun with it and wrote some rants, right? Like, like if it causes inefficiency, like the code that uses it just ends up being slower than you would like or whatever, we'll see that, like we'll have the data. Like, that's the thing is I'm totally like, okay, sometimes when people have ideas, they're super protective of the idea and don't want to admit when it didn't go well or whatever. But when a project is big enough, so like in The Witness or whatever, right? Like the game got to a point where it was big enough and it was good enough that I didn't feel like the core idea was in danger. So it becomes much easier. I mean, you already should have this ability to objectively judge things as best as you can, but it becomes easier to look at a puzzle and say, yeah, that puzzle isn't good or whatever, because it doesn't have to be good because the rest of the game's already good, right? And so we're just making it a little better. And that's how I feel about this whole system is like, it's already good. It's got some things that are not optimal, but it's already very interesting. Like, it has many different ways, like a system should have at least one good reason why it should exist, right? And this one has many, and it's fine. Like, it's good. So, when I do something like this, like, okay, if it's not good, it's fine. It doesn't endanger the rest of the thing. And it just gives it, like, I got some assembly programming experience and all that, and I got some rant writing experience. So, yeah. Louis C.K. line is a good ending. Right. So the question is, do we delete this paragraph or not? Yeah, I mean, this is basically, I don't know. What if I just say this? How's that? Because I just want to have a little bit of a callback to the actual question. Because, people might feel like I got far from the question. So I'm returning to the question here. It's not about the destination, it's about the journey. No, here I'm definitely saying it's about the destination. Yeah, dude, if somebody... So Casey, this is weird because there was a small version of this coordination problem during COVID, right? Like, even within the US, if after the first 6 months of COVID, somebody had declared, this is the new city where all the awesome, competent technology people are going to move because San Francisco and LA suck now. Like, that could have been a big thing. And it's just like nobody did it. Right? Like, even if it was a small town, there's like lots of people who would have been hyped to move to a small town with other smart people and just work remotely. And nobody did that. And so it turned into Austin and Miami and Nashville and fucking Jackson Hole and a few other places, right? So like, I guess the question is, what does that mean about whether somebody is willing to do that on a country level? I don't know. Like, dude, like Estonia, I mean, the problem with Estonia is it's too close to Russia now, but like some place like Estonia could say that, like, dude, we're just going to do this and it would be awesome. Yeah, I agree. It's a huge missed opportunity. I agree. Okay. Okay, you know what? That might be the whole rant, guys. Are there any other questions that I should cover? So we start this file with 173 lines of ranting. That's great. Who is harassing them? Dude, I am constantly harassed in the US. Oh my God. Czech Republic has a good tech scene. I kind of like Prague, but parts of Prague are definitely a shithole country. And that was before COVID. But parts of Prague were really nice. And in Prague, you get the cinnamon Czech churros, and those are really good. I forget what they're called. I'm just going to put these in one place. We probably want a lerp for these. We maybe want that. Okay, and then if we establish, I mean, that's kind of it for the rant. Will Apollo time be immune to time zones? Apollo time, we should have a comment here about this. Maybe we don't. I thought we had it. We should say this. Apollo time does not have time zones because it is a measurement of objective reality, and time zones are about how you talk about what time it is. So it's not correct to take an Apollo time and like add hours based on time zone or whatever. Instead, what you do is you say, give me the calendar time, right? Which is how you talk about a certain time, and then calendar time has a time zone in it, right? This is a lot like struct TM in Linux or something. It's just a little bit different. But like you don't adjust Apollo times based on time zone, because that's like you're just asking for bugs if you do that. Get rid of daylight savings time. Yeah, I wish I knew how to do that. Yeah, let me look up. Oh, I say explain not time zones. Okay. Apollo time represents a time in objective reality relative to the moon landing. I mean, you know that. It does not get adjusted based on what time zone you're in. Adding and subtracting hours to Apollo time is not the right way to implement time zones. And if you do this, you are inviting weird bugs and generally asking for trouble. Time zones are not a property of time passing in objective reality. They are a choice we make when we describe what time it is. Thus, we have another struct calendar. We have another struct calendar time that is meant to help describe time in ways that humans find convenient. You can convert from Apollo time to calendar time, and when you do this, you can supply a time zone for the conversion. Okay. That's at least a little bit of a better description. Swatch internet time. What is swatch internet? How do I not know what swatch internet time is? That is also resistant to leap seconds. Yes. The same goes for leap seconds and other calendar adjustments. These are not properties of time passing in the physical world, so Apollo time does not know or care about them. Apollo time is dead simple. The word dead, let's not use that there. Apollo time is very simple. Leap seconds, day skips, and so forth are aspects of calendar time only. Yeah, I don't know. Okay, I'm kind of getting tired. Maybe it's time to sign off. We finished probably enough documentation. I do want to do some more code revamp at some point, but not even that much, right? Like, to deliver this value to the people, we just need to check what happens with negative numbers and do appropriate things. And I don't think that'll take that long. Let's make sure I didn't typo the file. Yep, that's great. So, yeah. So, yeah. Yeah, I will say, since I moved out of California, I don't feel like I'm being pooped on every day anymore. So it's a little bit better, but yeah, like being in the US now is not that good. I do admit. Are people in the street harassing? Well, yeah, you get harassed all the time on the street, but that's not the problem. The problem is the people who run the city of San Francisco telling you it's your fault that you're getting harassed on the street. It's like the hugest gaslighting ever. It's like you're a bad person, and that's why people are walking around San Francisco yelling at nothing and or themselves and lashing out at people who walk by and then pooping all over the sidewalk. It's because you're a bad person that they're doing that. Yeah, not inviting Tesla to the EV car summit. That's such a huge fuck you. It's so insane. Like, how do they expect anyone? That's the ultimate clown world thing. It's like you can see the clown nose on them when they do that, and they still do it. Like, I don't know. Yes, we need all the very productive electric car makers like General Motors at the summit. It's like, really, guys? Like, there's no better way to say this country does not really value, like, all this shit that I just said about landing on the moon. It's like they're just saying the opposite. They're like, we don't value this engineering and this competence. We don't value the hard work and successfully creating electric cars and fucking getting people to buy them. Nobody thought that was going to happen. Nobody believed Tesla was going to be successful, and they somehow did it. I mean, not literally zero people, but like, dude, I had an electric car back then. I remember what the attitude was. It was very negative. And so to like have people succeed at that, and then you just say, okay, fuck you, you don't matter. What matters is who's our friends. That is a country that is setting itself up for failure, right? Is just what that is. And the fact that they think they can do that and people don't see exactly what they're doing is insane. It's insane. Setting itself up or has already failed. I mean, we kind of already failed, but things are recoverable, right? Like if we started doing everything right, we could recover pretty good. So I don't think it's an irreversible failure, but I don't think already failed is an exaggeration. I think already failed is true in the sense that if we don't change what we are doing, the outcomes will continue to be more negative over time, right? And that's obvious. That should be obvious to anyone, right? Unless somehow we get like 15 more Elon Musk type people who all do things just as huge that have as large of an impact, and they can somehow offset everything negative being done organizationally, which seems very unlikely for that to happen. Best we can give you is metaverse. Well, we're screwed then. I was talking to some people at dinner today who were not in the computer industry, and even they knew metaverse was bullshit. So, people ain't buying it. People ain't buying it. All right, so hopefully we have ranted in a way that will provide a positive message to somebody in the world. We'll see. And I think that's going to be it. Have I ever met Elon? No, I was like at one of the Tesla parties, one of the relatively early ones, and I was hanging out with someone, and there was a time like after the thing when people could like go up and shake hands with him and say hi, and the dude I was hanging out with did that, and I didn't because I was like, I don't want to be one of these people in the crowd going, hey, so I didn't, but I could have done that. It's just not my style, you know. I don't see the point of it. Unless you think that getting Elon germs on your hand will somehow transmit the positive success mitochondria. Maybe that's how it works. I don't know. I don't actually know. It might. Yeah, the midichlorians. Yeah, if you got the midichlorians from Elon, then it would have been a cooler story. It wouldn't, though. The story would have been Elon was being surrounded by dudes who all wanted to talk to him, and he was just trying to make his way for 5 or 10 minutes after the thing, and I was one of those people. And said, hey, Elon, thanks for everything you're doing. I'm a big fan. Like, that's not a good story. All right, thanks, everybody. And we didn't actually do any. We did a little bit of programming. Never mind. I almost said we didn't do any programming, but we did. We tweaked these, and I feel even better about these now. They are better. Better. It was a small amount of programming, though. All right. Good night, everyone. See you later.